All right, so looking again. Okay, so these are the four the four sections for the quiz. So starting at the bottom, separation of variables. So this is the one we did in class. So just to go through the basics of it, we have x and y. We have a differential equation. We're going to separate the y's and the x's. We're going to make that dy over dx. So we're going to divide the y squared to this side. We're going to multiply the dx over to that side, separate them out. Usually when we divide, we write it like this with the 1 over y squared. Then we're going to do the integral of both sides. So you'd write that as a power, do your power rule. Then you got to get the y by itself. Now in this particular one, negative 1 over y, to get the y by itself, you're going to invert, right? You can just flip, multiply the y over, divide, however you want to say it, but you do that. Now that's called the general solution. Once you get the y by itself, that's the general solution. Now if you want to clean it up a little bit, multiply top bottom by 2, that kind of thing. If you do, you multiply by 2, you get 2c. You can still call that c, that's fine. Either one of those are acceptable. That's your general solution once you get the y by itself. Because remember, that's the solution to a differential equation, is the original function y written by itself. Now, if they give you initial condition, you need to plug that in, find the c value. So we went on from there. We said, well, if you did the first version or if you did the second version I had there, you put in your initial condition, you find the c value, then you write that. That's called the specific or the particular solution. And that's basically it. Okay? So now in the other class, they had questions. They wanted to talk about 27 and 30. You want to look at those at all? 30 for sure, I think, was kind of interesting. And 27 kind of had an interesting take on it as well. If there are any before then, we could look at those too. But 27, when you have this 1 plus y squared, how do you deal with that? Can you separate the 1 and... No. What do? You treat that as one whole thing and you divide it over. So you're going to move the dx over to this side, and then you're going to divide that whole 1 plus y squared like that. Now when you go to do the integral of both sides, stick a 1 in there, integral of this. Now what's the antiderivative of this? Good, arctangent. Now, here's the thing. You know, I'm going to stick on this quiz with fairly basic antiderivatives that you should be able to do. But, I mean, that's one we should be able to do. I mean, that one's a little out of the ordinary. I haven't done some of those for a while. But, you know, we should be able to deal with that. And so if you get that, so this would be arctangent y. Oh, and why don't we put a plus c there? Yeah, we're just going to subtract it over, and there's a c on the other side. When you subtract two constants, you get another constant. So we don't put it on that side. Antiderivative of 1 is x plus c. Now the tricky part here is getting the y by itself. What do you do to both sides here? The tangent. So if this would have been tangent y, we would take the arctangent of both sides to get the y by itself. So right here we do the tangent of both sides. And we get tangent, and make sure that plus c is inside the tangent. Okay? Now, and let me make another comment. This is not a natural log problem here, right? Some people, whenever they get a 1 over something, they think it's natural log. That's not true. If it's 1 over y, 1 over a constant. Now, I did another one. Let me back up here a minute. I did this one. This is one I had up here when you came in the room. This is one we talked about in the other class too. This looks very much like the one we just did on 27. You're going to move the dx over. You're going to divide by that. But now this is a natural log, because it's a first power. So on this one, the antiderivative is that. And then you got the x plus c. And then you would do your e, you know, e raised to the x plus c equals 1 minus y. And then you got to get the y by itself. And then we also talked about that thing where you had e to the x plus c, where you can split that like this, e to the x times e to the c, because you add the powers. And e to the c is just another constant you pull out in front. So you could write it this way. Either of those I would actually accept. Either one of those would be fine. So anybody see a problem there? Or everybody okay with that? I'm kind of testing you because this is another one I screwed up this morning. And nobody in the other class caught it. I said, well, I'll see if third block catches Kind of ran through that pretty fast. My antiderivative is bad. Not real bad, just a little bad. From here to here, I did something wrong. No. You're close. Should have kicked out a -1. Should have kicked out a -1. I know. It was a bad morning. Kicked out. I should have kicked that right because the derivative. Because think about it. Check your antiderivative. Do the derivative. So the derivative of this would be 1 over 1 minus y times the derivative inside. Derivative inside is -1. So I should have kicked out a -1 right here. Which means when I did the negative over here, I should have had negative on both sides here. Now -x, -c is, I would just leave out plus c probably. So that should have been negative, which means that should have been negative, which means that should have been negative. That should have been negative. That is actually what it should be. Okay? So anyway, little things like that, we got to make sure we do. We do the antiderivative. Now, another thing to keep in mind on these separation variables, on the AP test, in the free response section, I'll kind of grade it the same way. These are usually worth 4, if not 5 points. Here's how they usually do the points. They give you a point for separating them right. They give you a point for doing the right antiderivative on this side. They give you a point for doing the right antiderivative on this side. So in this problem, I'd have got a point for separating them right. I'd have got a point for doing the right antiderivative over here. I'd have lost that point. But then, solving it for y, if I did the rest of it right, even though I forgot that negative, I would have gotten the point for solving it right because mine didn't have a negative on it, so I solved it right with mine. So I'd have gotten 3 of the 4 points, just even though I missed that. Okay? So something to keep in mind. Oh, and before I go back, I'm sorry, before I go back to 27, I forgot there was this question on 20, but I think some of you guys got to this at the end of the day on Wednesday. You can't get y by itself on this one. On this one, when you multiply this over here, you multiply the dx over here, you do your antiderivative, you can stop right there. You just can't get the y by itself. And to be honest, a lot of times on these problems on the AP test, you don't get a point for solving for y anyway. You get a point for splitting it, you get a point for doing the right antiderivative, another point for getting this right antiderivative, then you usually get a point for putting in your initial condition and getting the right c value. Sometimes if it's one they expect you to get the y by itself, then you might get another point for getting the y by itself. But you should, as a habit, do that. But then sometimes you just can't get the y by itself. Okay? So anyway, back to the one we were doing. All right, so we get to this point. So you could have got a lot of the points by just getting down to here. But I think on this one, I would give another point for getting the y by itself. Okay, now, did this have an initial condition? What if it would have given you the condition y of 0 equals 1? Let's talk about that real quick. What if they would have given you this initial condition? Put a 0 in for x, put a 1 in for y, and you'd have tangent c equals 1. Well, when does tangent c equal 1? Pi force over here, but I wouldn't worry about that because you have a lot of different c values, so usually it would be limited a little bit or whatever. I would just find one that works because basically that's what you need is a solution. So you get y equals, so I would say c equals pi force. So your y would equal tangent and then x plus pi force. So you might have to be able to do some trig and those kind of things when you are solving for your c value, when you put your initial condition. But on that one they didn't. So if they don't give you initial condition, you just find your general antiderivative. Okay, now number 30. Now number 30, separating it's not hard. You get this. And over here you multiply your dx, so you just have a 1 there. Here's what was hard about this, and I don't expect to do, I will not do this to you on the quiz tomorrow, but it could show up, in the finals and so forth. The hard part here is doing the antiderivative on the left side. Anybody come up with anything there? Put it into your calculator. That's true. On the quiz tomorrow, I said you could use a calculator, right? Anybody recognize this?
Wait a second. Don't you have to use that property where you can put the number up
No. I don't think I've heard it yet. It's a U substitution. See, I think we could have done this fine back when we were doing the gateway. We're a little rusty on that now. What would you let U equal? Let U equal ln y, because what's the du? 1 over y dy, which is setting right there. So you let U equal ln y. See, well, think about it. When we do separation of variables, the whole point is to separate it into two integrals, then we got to be able to do them. Well, we learned about how to do these different antiderivatives, so we may have to use those techniques. Now, again, I'm not going to get into that tomorrow. I'm going to use a calculator and so forth anyway. But this substitution would just be, you would take that out and make it u. The rest of it would be the du. So this is just 1 over u du. So that's ln u, but u is ln y, so it's like a double ln. It's like ln of y. To be honest, the different absolute values end up not really mattering here. And then on this side, you have x plus c. So to finish 30 out without a calculator, now again, that's another reason this isn't a big deal for tomorrow, because you can just solve this on your calculator at some point along the way. You can just type that all in. So that's why I'm not going to give you any like that. There'll be ones that would be just as easy to do without a calculator as they are with a calculator. But how would you solve something like this without a calculator? It would be e, raise it to the e twice, right? In other words, start on the outside, and so you go e to the x plus c is equal to ln y. Now we know that e to the x plus c is the same as just that, right? If you prefer to do that, usually that's how to write. And then we just do it again. E raised to that, so e raised to the c e to the x equals y. So it ends up being something like that. So to solve kind of this double ln, it's just e raised to that equals that, and then do it again, and away you go. All right, so those were a little more interesting there at the end. But that's the basic idea of integration by parts. Split the x and the y's, do the integral of both sides, get the y by itself, put an initial condition if you have to. All right, so if we go back to what we were talking about, so that's separation variables. So maybe 1, 2 of those tomorrow, probably at the most. Then you get back to the work stuff here, the spring, the rope and the bucket. Just talk briefly, probably on your own here. Go back, I think in the homework assignment we did in section 7.3, there were 3 different rope and bucket problems. One was an elevator with a cable, but it's basically a rope and bucket. So go back and redo those if you need to. But, it was a basic thing. You had so many feet of rope you had to pull up. Maybe the rope weighed 0.8 pounds per foot. So 20 minus x is the amount of rope you have. 0.8 is the pounds per foot you have. You multiply that. That's basically the rope. That's the pounds of rope right there. The bucket, if it's not leaking, you just have plain old pounds. If it's leaking, then it's just like this. How many pounds per foot is it leaking? And you have the same sort of equation. So we did that. So again, you have several of those you can go back and review. The spring problem, we had force equals k times x. Here was one we talked about in the other class, so I could just walk through this. The spring problems all started with a natural length, some natural length of the spring at rest. The spring at rest was, say, 3 meters. If we're going to stretch it to 5 meters, we use this formula. That means x is 2 because we stretched it 2. If it takes 60 pounds to do that, every spring problem is going to look the same way. Okay, if it's stretched 60 pounds, that's your force. So K is 30 for that particular spring. So then if I ask you how much work to stretch it from 5 to 8, that means it's stretching from 2 to 5. Because 5 meters is already stretched 2, 8 meters is stretched 5. So from 2 to 5. And then 30, you already found K was 30, so your equation is 30x. I mean, that's just it. That's all there is to it. So you had a spring problem that you did in your homework. Something like that. Now, when you get into Calc 2, if you guys are going to take Calc 2, but you'll do a lot more with the work problems and get into some more situations. But we just want to touch on it here a little bit. Not something you'll see in the final. So, Might be, maybe 1 or 2 problems tomorrow. That's it. All right, so that was the work stuff. And then we've got the section 7.1 and 7.2. Now, we already kind of went through the whole volume. We did the layer, the shell, the slicing. Don't forget your squares, your equilateral triangles, your semicircles, that kind of thing. We had a couple different formulas for semicircle, the 1/2 pi r squared or the 1/8 pi d squared, because the diameter of the strip was the diameter of the semicircle. But then at the very beginning, 7.1, we started with just area between curves. So it was just top minus bottom, right minus left. So if we were doing an area, like what you see over here, the length of the strip is the height, the dx is the width. Multiply those together, that's the area. The integral adds up the area of all the strips. And that's all you got is area. So, that was where we first learned that. So those are pretty straightforward. Probably have one of those tomorrow. And then maybe one of these, the length of the curve. And that was that formula. 1 plus, somebody in their class asked, is that f prime all squared? So I rewrote it here. So if I'm doing the function sine x, and I want to know how long is sine x from 1 to 4, I just do the integral from 1 to 4, and I plug it into this. So the derivative of sine is cosine, so it's 1 plus cosine squared, all under the square root. Type in that integral, and away I go. Okay, so that's just a formula you got to memorize, just length of the curve. So that's it. Separation of variables, the work, area between curves, length of a curve, and then, that's 5 or so problems, and then half the quiz. The other 4 or 5 problems would be, volume. So, various types of volume. Questions? I kind of ran through that pretty quick. Questions? Yeah, Keith.
For the semicircle, for the volume by slicing.
Yes.
Is the D the same as?
Yeah, great question. The S here, now, the reason I used S here was I was thinking of when I have a region. Okay, so let me just draw a region here. So let's say I've got some region like so. And that is the base of my region. And they always tell you in the problem that the slices are perpendicular to a certain axis. So let's say they were perpendicular to the x-axis. So this strip is there. Okay, so now, if I'm doing square cross-sections, I've got squares coming up off of the page here. So this strip is one side of the square, and that's why I used S. Or if these are triangles coming up off of the screen, then that strip is one side of the equilateral triangle. And that's the equation. But if I've got semicircles coming up off of here, then this strip is the diameter, right? And so I use the D. So your question to me is, and this is what somebody in their class said, they thought of S as the strip, right? They thought of S as standing for the strip, and then that works too. So in that case, this would be like S for the strip. This would be the S for the strip, and then D would be like the S for the strip, right? I just want to make sure you understand that that's because that's the diameter of the circle. So that's why we kind of like this equation better than this one. Because the R is not the strip, it's half the strip, right? So you'd have to do the top minus, but you have to do your strip and then cut it in half and then put it into that equation. And sometimes that got a little confusing. I know in the past, sometimes that's been confusing. So we've kind of went to using this formula, which makes it a little easier. So long answer to your question, Keaton, but yeah, the D is the same as those S's there. Okay, and then the other thing I wrote down over here is a P. Remember, we did a shell method already, but P is that distance from the strip to the center. So the strip is always labeled with an X or a Y, depending on if it's horizontal or vertical. So your P is always kind of 2 minus X, Y minus 3, Y plus 2, something like that. And then H is just the length of the strip. So that's just your top minus bottom, right minus left. Okay? All right. Well, that leaves us some time to what I've got here is a little worksheet with some volume problems. So I thought for sure we'd want to do those. Now, I think you're kind of on your own to review the other things, the work, separation variables. We spent a fair amount of time on here. So there's not, I don't really have much to review on that other than, you know, the homework you already did. You know, the work, the rope and the bucket, you know, maybe go back and look at some of those we did in our homework there, make sure you understand those. There's that spring one, number 1 on the homework from that page. And then back in the LH packet, in the very first assignment we did, had some of the area between curves, and so you can certainly go back and look at those. But on this worksheet now, you really only need to do 1 through 4 right now. 5 and 6 are problems that we will probably come back and look at and attempt, but they are a little beyond what you have to do for the quiz. You're certainly welcome to do them and think about them and try them. We probably will talk about at some point, but they are not going to be ones you'll have to do. But 1 through 4 are very much like ones you would be asked to do more. Okay? Yeah?
The quiz tomorrow is all calculated.
All calculated, whole thing. So it'll be a lot of sketching the region and setting up the integral and then getting the answer.
We get to a volume problem on the quiz.
What's that? Yeah.
Will it say do this by using the shell method, or will it just say use either?
My feeling right now is I'm probably going to not tell you a method and you get to choose. So for example, but there'll be some where one method is definitely easier than another. There might be one where only one method works, right? Keep in mind that horizontal strips only work if you can get x equal. If you can't get x by itself, then you have to do vertical strips. And remember how we talked about sometimes a region has to be split into 2? If you do it one way, it has to be split into 2, and maybe that's the only way you can do it, so you might have to split into 2, that kind of thing. So that may happen to you, but I'm leaning now towards not really telling you a method, and if there's one that's easier, go with that one. If you want to do them both, double check. Now on the worksheet, as you will find out when you come up here to check your answers, I got the answers up here. If you can do it both ways for practice, that would be a pretty good idea. So on number 1, if you have an option to do shell or disc, I do them both just for practice. And I've got both of them worked out up here. So but that's kind of how it's probably going to be on the quiz. You'll just have your choice.